All right, so I'm gonna walk through this lesson, these guided notes. Um, it's possible some of you can figure a lot of this out just by intuition. It's not the most challenging stuff, um, not necessarily easy either, but I'm just gonna go through it, and you can always pause and just do some stuff on your own if it's going too slow for you. Okay, so we want to just dive in a little bit more into Riemann sums, and these are the sums that we use to approximate area under the curve. And there's really four main types: a left hand, right hand, midpoint, and trapezoidal Riemann sums. We talked about left hand and right hand in our last class, and we sort of mentioned the idea of midpoint and trapezoidal. So it should be somewhat familiar. So I wanted to start by looking at the same problem, um, but doing left hand, right hand, midpoint, and trapezoidal. So what we're going to do is we're going to approximate the area under the function f of x equals 2 minus cosine x. So this is cosine x reflected and then moved up 2. You can see the center line is at 2, and its range goes from 1 to 3 on the interval 0 to 6. So we're not going to actually compute these fully, but I'm just going to show you how we would. And most importantly, I want to accurately draw each of the four types of Riemann sums to make sure we know what they look like. So first of all, we're going to start with a left hand using 6 subintervals. Remember, we're going from 0 to 6. So our subintervals, if we have 6 of them, are going to be every 1 unit. Okay, of course, starting at 0. So that should give us 1, 2, 3, 4, 5, 6 subintervals. Now, if we're going to do a left-hand sum, we're using the left-hand side of the subinterval as the height for that rectangle. Left-hand side, height for that subinterval. Left-hand side and top it off. Left hand and top it off. Left hand and top it off. Left hand and top it off. So you can see some of these are underestimating the area and some of them are over. And that has to do with whether the function is increasing, decreasing. Now, what would this sum be? Well, each rectangle has the same width, which is nice. That's not always true. Sometimes we're given problems where it's the same width, but in this case, it's all the same width, which is 1. And so we can just do 1 times each one of our heights. Now, our heights are found by f of 0, f of 1, f of 2, f of 3, f of 4, and f of 5. So it should be 1 times f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4. Will this move over? No, plus f of 5, right? And that should give me 1, 2, 3, 4, 5, 6 rectangles, which is what I expect. Now you might say, well, what is f of 0? Well, of course, I could plug f of 0 into this function to get that actual value. You can see that it's actually 1. I'm not going to plug in all of those things at this point, but we definitely could, and we get an approximation for the area under the curve from 0 to 6. Now, I will just show you some notation here. When we want to say the area under the curve from 0 to 6, we write what's called a definite integral. So we say 0 to 6, and then we would say 2 minus cosine x dx. It looks very similar to the anti-differentiation notation we were using before, but it has bounds. So this means the area under this curve from 0 to 6. This Riemann sum approximates it. Okay, so using a right hand, again, same subintervals, so we can cut that up quickly. But now we're using the right hand side. So we take our first subinterval from 0 to 1, we go over to the right hand side of it, go up to the top and make a rectangle. Go to the right hand side of the second one, go up to the top, make a rectangle. Go up to the top, make a rectangle. Go up to the top, make a rectangle. We're going to the right hand side here. So again, you can see that sometimes it over approximates, sometimes under, depending on whether the function is increasing or decreasing. So again, all of our uh, rectangles have the same width of 1 in this case, and we'd be multiplying by f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. right? And again, that's 1, 2, 3, 4, 5, 6. We're starting at 1 and going to 6, which is 6 things, as opposed to starting at 0 and going to 5. Okay, and that also approximates the area from 0 to 6 under 2 minus cosine x. This is approximately equal to this. Okay, let's talk about midpoint. So midpoint, again, we're using 6 subintervals here, but instead of using the left-hand side or the right-hand side, well, you guessed it, we're going to use the midpoint. So we're going to find the midpoint of each subinterval, and we're going to use that y value as our height. And this is actually generally the best approximation using the midpoint. But it is a little bit more work often. So that would be the midpoint. So if we make a rectangle with that height, you can see that it is going to both over and under approximate each time, and it might kind of cancel out a little bit. So you can see how that, whoopsies, that wasn't correct. You can see how that might be a good approximation. In red, I'll just show you, these are the little over approximation pieces, right? And then in blue would be our missed area here. But you can see how those things might be very similar and cancel each other out in some ways. And so our midpoint sum would then be, again, a width of 1 for each rectangle, but now we're plugging in the midpoint. So that's going to be f of 0.5 and f of 1.5 and f of 2.5 and f of 3.5 and f of 4.5 and f of 5.5. So you can see the difference here where with our left hand we used 0 through 5, our right hand we used 1 through 6, and our midpoint we're using halfway in between. So 0.5 up to 5.5. Okay, finally, trapezoidal. So it turns out that the trapezoidal sum is just the average of left hand and right hand. So I usually just compute the left hand and the right hand and average them. That's one way to do it, literally add them up. But it's good to look at how we would compute it without doing that as well. Trapezoid basically just means that we are connecting this straight across. Okay, so we're making a little trapezoid here. Trapezoids have two parallel bases. So in that case, that's this base and this base. And then the other sides, the legs of the trapezoid can kind of be whatever you want. But anyways, these are trapezoids, and it wouldn't be hard to see how this would be a better approximation than the left hand or the right hand. So what's actually happening here is instead of what we did here, we kind of averaged the x value. We found the middle of the x value. Here, we're averaging the y value to find our height. So what we're going to do is we're going to take that same width, but now instead of multiplying by f of 0 or f of 1, we're going to multiply by the average of f of 0 and f of 1, right? And so essentially what you're doing is you're finding this rectangle, and you're averaging them to get the thing in the middle, which would just be drawing a line straight across. Okay, so that's just for the first rectangle. And then for the second rectangle, your height would be the average of f of 1 and f of 2 divided by 2. And then for the third, it would be f of 2 plus f of 3 divided by 2, etc. Now, you might be thinking, wait, isn't that just the midpoint? Well, no, not necessarily. It could be in some cases, in some specific cases, like maybe if the function's linear. But here, what we're doing is we are averaging the y values. And up here, we're averaging the x values and then plugging it into the function. So we're finding the midpoint x value and plugging it into the function. Down here, we're finding the left-hand and right-hand values and then dividing by 2. It's not hard to see how this is going to be the average of the left-hand and right-hand. Okay, so those are our 4 different types. Now we've got to do some work with them. It's very common for these sums for you not to have a graph, but rather to have some sort of tabular data. So I'd like to show you an example where we've got the same tabular data and we are going to do a left-hand, right-hand, midpoint, and trapezoidal Riemann sum. So here's the scenario. Tiffany posts a picture of her posing with Sir Isaac from the pop group Sir Isaac and the New Tones, haha, on her Instagram at 9 a.m. The rate that her followers view her picture is modeled with selected values shown in the table where t equals 0 represents 9 a.m. Okay, so here's 9 a.m. So that means this is 11 a.m. and 1 p.m., 2 p.m. This is 3 p.m., 6 p.m., and 9 p.m., right? Okay, just so we know. The rate is measured in people per hour. Okay, so 41 people per hour at 9 a.m. By 11 a.m., it was down a bit. Use a left Riemann sum with 6 subintervals to approximate the area under p prime of t on the interval 0 to 12. Interpret this approximation in the context of the problem. Okay, so left hand, if we are going to do a left hand sum with 6 subintervals, we're going to use the left hand values. So that is this value, this value, this value, this value, this value, and this value, right? Those are the y values on the left-hand side of each interval. The tricky thing here is that these subintervals do not have the same width, right? So for instance, the first subinterval has a width of 2 and the second interval has a width of 2, but then the third interval has a width of 1, right? How am I getting those numbers? Because I'm looking at the x values or the t values. 0 to 2 is a change of 2, 2 to 4 is plus 2, 4 to 5 is plus 1, 5 to 6 is plus 1, 6 to 9 is now plus 3, and 9 to 12 is plus 3. Those are the widths of our rectangles, and they are changing. So we got to be careful to use the right width. And then our heights, we're going to use the left-hand side of this subinterval. So the mathematics is very simple. It's just a matter of setting it up. Okay, our first subinterval was 2 hours from 0 to 2, and we're going to use 41 people per hour as our height of that rectangle. Then our next subinterval also had a width of 2 or a time of 2 from 11 a.m. to 1 p.m. or 2 to 4. And we're going to use, again, the left-hand value for that subinterval. Okay, from 4 to 5 is a time of 1 hour, and we're going to use 54 people per hour. Again, we had from 5 to 6 is 1 hour, and we're going to use 26 people per hour because it's on the left side of this subinterval right here. Then we had a time period of 3 hours, and we're going to use 21 people per hour, right? Which makes sense. If it's 3 hours, 21 people per hour, we want to count that as about 63 people, so it's 21 per hour. And then our last one, again, is a width of 3. 3 hours had passed, and we're going to use 44 people per hour. Now, I don't have a calculator on me at the moment, or do I? I guess I do. But I'm just going to ask you to find this value. This shouldn't be hard to find at this point. Interpreting this in the context of the problem, this is going to be the total number of people who viewed the post from or maybe between 9 a.m. and 9 p.m., right? So it's going to give us that approximation. Makes sense that 2 is hours and 30 is people per hour. So those hours are going to cancel and we're going to get people, right? Which is what we had here. Okay, so for right Riemann sum, we'd have the kind of the same thing. It's just that instead of using, right, if we look at like this subinterval here, which goes from 0 to 2, instead of using the left hand, we're now going to use the right hand value there. So it's going to look very, very similar. It's just that we're going to be using the right hand value. So not to bore you here, but the widths are the same. So it's 2, but instead of multiplying by 41, we multiply by 30. It's 2 again, but instead of multiplying by 30, we use 54. Okay, it's 1, but instead of multiplying by 54, we multiply by 26, etc. Now 1 times, let's see, 21, and then 3 times 44, and then 3 times 11. Okay, so that is going to give us a different approximation. We're still using the same time intervals, 2, 2, 1, 1, 3, 3, but we're multiplying by the number of people per hour measured at the end of that interval instead of at the beginning, right? That's the difference between left and right. Okay, midpoint Riemann sum, you'll notice I highlighted this. It's 3 subintervals because there's no way for us to do a midpoint with more subintervals because if we wanted to do the midpoint for the interval 0 to 2, we would need some data at 1 because that's halfway in between, and we don't have that data, so we can't do that midpoint. However, if we do 3 subintervals, let's think about what those subintervals would be. That would be from here to here, that's 1 subinterval. From here to here, that's 2 subintervals. And from here to here, that's 3 subintervals. And so for our heights, we're going to use the middle y value. This, and this. So those are going to be our y values. We need to be careful about what our widths are, right? From 0 to 4 has a width of 4. From 4 to 6 has a width of 2. And from 6 to 12 has a width of 6. So these are, the number of hours or the widths of those rectangles, and we're going to multiply by the different heights using the midpoint. So that's going to be 4 times 30 plus 2 times 26 plus 6 times 44. Now, this is not going to be a better approximation probably because we had way fewer subintervals, but that would give you an approximation for that area using the midpoint Riemann sum with 3 subintervals. Trapezoid, the easiest way at this point to do that would be to, if this is answer A and this is answer B, to just average those. Do A plus B and divide it by 2. How that would look if you hadn't already have done that. Well, first of all, we've got the same widths because we're doing 6 subintervals. So we know the first width was 2, and then we had another width of 2, and then 1, and 1, and 3, and 3. That's not really enough space, so I better not write all that out. But remember, if we want to find the height for, not really the height, but what we're going to multiply for our trapezoid, we take the 2 heights and average them. So if our first subinterval goes from 0 to 2, we're going to take these 2 heights and average them. Okay, so it's kind of an average, or it is an average of the left and right hand. So that's going to be 2 times 41 plus 30 divided by 2, plus 2 times 30 plus 54 divided by 2, plus 1 times 54 plus 26 divided by 2, plus 1 times 26 plus 21 divided by 2, plus 3 times 21 plus 44 divided by 2, plus 3 times 44 plus 11 divided by 2. So if you compute that whole thing, you are going to get the average of the left hand and the right hand sum. Okay, so that was a lot just to start with there. I'm going to pause this video so I can clear my throat, and then I'll start up with error.